Next, I'm going to talk about data frames. Here, I've made an example data frame by calling the data frame function with two arguments, the RT vector and the difficulty vector that we were working with just a second ago for example data analysis. And I took the result of that data.frame function call and stored it as an object called RT_study. And this is what that object looks like when I print it to the console. This is a simple data frame made of those two example vectors. A data frame is, in general, a list of vectors. We usually think of it as being like a spreadsheet, visually represented as a rectangular table like this. And that's because all of the vectors in a data frame have to have the same length. Usually each element is an observation from an experiment, and the columns represent different variables measured for each observation. Just like with a vector, we can use square brackets to retrieve part of a data frame. But a data frame has two dimensions, so we don't just specify the element index, we specify two indices, one for the row number and one for the column number. For example, here, I asked for the RT_study object, but I used square brackets to specify that I want row 4, column 1. Before the comma in the square brackets comes the row number, and after the comma comes the column number. So 490 is the number of milliseconds that it took for the fourth participant to react to whatever this experiment was about. If you leave the space after the comma empty, then you'll get the whole row. So 4, nothing gives me all of the data for case number 4, RT and difficulty. And if you leave the space before the comma empty, then you'll get the entire column. So RT study square bracket nothing, 1 gives me the entire reaction time column, the entire first column of the data frame. Retrieving a specific column from a data frame is a fairly common thing to want to do, so I'm going to show you two other ways of doing it. First, you can specify the column name as a string after the comma in the square brackets instead of specifying the column index as a number. So here I've got nothing, quote, RT, end quote. This is the name of the first column, and I get the same thing, the entire first column, the entire column named RT in that data frame. But most conveniently, you can provide the name of the data frame and use the $sign operator to retrieve a specific column by name. So RT_study $RT is the reaction time column from that data frame. Sometimes it's nice to see a vector of all of the names of a data frame. We can get that using the names function. Here I've called the names function with one argument, just the name of the data frame, and it gives me a vector indicating that there are two columns in that data frame named RT and difficulty. We can also add a new column to a data frame by using the assignment operator in combination with the $sign operator. So RT_study already was a data frame before this, but there was no vector called male inside of that data frame. It only had two names, RT and difficulty. What I did here was combine this set of zeros and ones into a vector and then assign it to this name within the RT_study data frame, creating a new vector within RT_study called male, where I suppose 0 is supposed to represent participants who were not male and 1 to represent participants who were. We can use vectors that are in a data frame in a statistical function, and in fact, this is most commonly how we're going to use most statistical functions in this class. So I can call the LM function, for example, with a formula that uses names that only exist inside the RT_study data frame. Here, RT tilde male indicates that RT is supposed to be the response variable and male the predictor. And I can use this second argument, data equals RT_study, to tell R that the names of the variables in this formula are supposed to be found in this data frame, not in the general R environment. So it's okay that there's no vector called male on its own. R is going to find both of these vectors inside of RT_study. The second argument to the LM function actually is the data argument, so I technically do not need to specify data equals in order to indicate that RT_study is the source of the data for this formula. But I usually think it's easier to understand what's going on if we explicitly specify the name of this particular argument, data equals RT_study. Remember, when you provide multiple arguments to a function in R, if you provide them exactly in order, you don't necessarily need to name them. But you can always choose to name them. This one's called data, and if you're going to provide them out of order, you have to. Most of the time, we're not going to create data frames to analyze in R itself. We're going to have data that already exists outside of R, and we're going to want to use R to analyze that data. So I'm going to show you how to read data from a file, and I have a CSV file prepared for this purpose. CSV files are a very standard way of storing data. When your data collection is complete and you're ready to start analyzing, it is fairly common that what you will have at that point will be a CSV file. And a CSV file is just a text file. Here is what this one looks like if you open it in a text editor. CSV stands for comma-separated values, and you should be able to see why. The first line of a CSV file has the names of the variables separated by commas, and the rest of the lines each have data from one case in the same order as the variable names, also separated by commas. In this case, this is an imaginary experiment about salary negotiations. Each participant watches a video of a job interview, rates the confidence of the interviewee on a scale from 1 to 10, and then makes a recommendation for what the negotiator's first salary offer should be. The experimenters varied the height and race of the interviewees. So the variables are height of the interviewee, race of the interviewee, confidence rating, and first salary offer. And the first row of actual data is in the second line of the CSV file. That participant evaluated someone who was 156 centimeters tall and black, rated their confidence as 3.9 out of 10, and recommended a salary offer of $105,000. Most of the time, people open files like this using a spreadsheet program, not a text editor. Here's what you'll see by default when you let Excel open this file. It's easier to see what's going on when it's represented this way, where the commas aren't explicitly visible, and instead the data is organized in rows and columns. We can read a CSV file in R using the read.csv function. In order to use this function most effectively, you should make sure that the file you're trying to read is in your working directory before you run the function. Here I called read.csv with a single argument, the name of the file I want to read, and I assigned the result of that function to a new object called negotiation study. Reading a file like this in R is easy. The read.csv function has default settings that work well with this kind of file most of the time. R knows where to find the file because it's in the same folder that R is currently running in, which we call the working directory. Most of the time, we just want to open R in the folder we're planning to work with in the first place. But if you want to check your current working directory or change it, you can usually do so in your GUI somewhere. In R GUI, this option is available under File, Change Dir. In RStudio, this option is available in the lower right quadrant of the layout by default. You might have to click on the Files tab to see it. You can specify the full path to the file instead of using a working directory, but I recommend against doing that. This way is less work for you and makes it easier to share your code with others who might not have the same file system as you. A win-win. Having read in this CSV file as a data frame, I can print the data frame to the console. Normally, you wouldn't want to do that. You wouldn't want to view the whole data frame at the console because it would be too big in most cases with real data. But in this case, I generated the fake data with only 32 participants so that it would fit on the screen for this demonstration. I'm going to show you two key functions to get information about the data frame. There's a lot of other things you can do to get general information about data frames, but for now I'm just going to focus on these two. The dim function stands for dimensions, and it tells you that this data frame has 32 rows and 4 columns. And as we've already seen, the names function gives a vector of all of the names of the columns in that data frame. In other words, a vector of the names of the vectors in that data frame, because each column of a data frame is a vector, and a data frame is a list of those vectors. We can refer to a specific variable by name using the $sign operator, just like we did with the previous example data frame. So negotiation study $sign salary gives me a vector of the suggested salary offers that the participants supplied in this experiment. This object is just a vector. We're using the $sign to retrieve it from the data frame that it's stored in, but once we've retrieved it, that doesn't matter anymore. Anything that we could do with a vector stored on its own outside of a data frame, we can do with this vector that we got using $sign as well. For example, we could compute the mean of negotiation study $sign salary, $106.5 thousand. We could compute the standard deviation, $31.1 thousand. We can also fit a regression model using the variables from this data frame. So here I've called the LM function, where the first argument is the formula salary tilde height, indicating that salary is the response variable and height is the predictor. And I've specified that both of those variables are vectors stored in the data frame negotiation study. In this case, I'll show an example where I store the result of fitting that regression model as a temporary object called salary height model. And then I call the summary function on that object. In this example, the relationship between height and salary is positive and not quite statistically significant. We're going to talk a lot more about interpretation of regression models in the coming weeks.